Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions for AP Physics 1, and in the last video, we have discussed some multiple choice questions for AP Physics 1, and for those questions, you can go to the channel and you can search for AP Physics 1 exam solutions part 01. And this is the second part, and in today's lesson, we will discuss more MCQs for AP Physics 1 exam. And we will discuss these questions in detail so you can improve your conceptual understanding of these topics, and also you can have better understanding of these questions. Let's study together, let's improve together. For question 6, it is given to us: a bubble in a glass of water releases from rest at the bottom of the glass and rises at acceleration a to the surface in time t seconds. We need to find out how much further does the bubble travel in its last second than in its first second. Very nice question. The best way is you can stop the video. You can do this question first of all by yourself, and then you can come back and you can compare your answer with my solution. You can stop, you can do first of all by yourself. Now let me explain to you how you can answer this. So the best way is we can sketch. We can imagine that bubble is here at the bottom of the water, and at this point velocity of the bubble is 0. It started from rest, and imagine that after 1 second, let's say this bubble is at this point. So here we have time t that is equal to 0, and here we have time that is equal to 1 second. And we can also imagine this distance. Imagine that this distance traveled by the particle is d1, and acceleration of this bubble is given, that is constant. So we can also simply draw this arrow here, and we can say a is the acceleration, because this is given. A is the acceleration of the bubble, and acceleration is constant. Acceleration is constant. Now we can imagine the last second. Let's say the bubble is at this point, and finally bubble reaches at this point in last second. We can also make this one a little bit. This distance will be greater than the initial distance because it has constant acceleration. So we can say this bubble is here, and in the last 1 second, let's say here we have time that is t minus 1, and time here, final time is t. So the time taken between these two positions, time is 1 second. We can also imagine that in this case, let's say this distance traveled, we can label this one d2, and acceleration is constant. Now first of all we will calculate d1, then we will calculate d2, and then we need to find the difference, because question is asking how much further. So it means you need to find that this difference in these two values of distance. So we can simply write down here delta t. This is what we need to calculate. d2 minus d1 we need to calculate. First of all, let's try to calculate d1. In order to calculate d1, we have time, we have initial velocity, we have a. So simply we can use ut plus 1/2 at square, plus 1/2 at square. So in this case u is equal to 0. So we have simply 1/2 a, and t is equal to 1. So we can simply write down in this case value of d1. d1 will be equal to a by 2. So this is value of d1. Now we need to calculate value of d2, and this part is a tricky part. First of all, let's try to calculate the final velocity. Let's say the final velocity of this bubble is v, and the initial velocity of the bubble is 0, and acceleration of the bubble that is equal to a. So simply we can calculate v. This one will be equal to u plus a times t. So the v will be equal to 0 plus a, and t is the total time. So we will simply say this is at. So we have calculated value of v. Now in order to calculate this distance we can simply use d2. This one will be equal to vt minus, this is the fifth equation for kinematic if acceleration is constant. So we can use d2 is equal to vt minus 1/2 a t squared. So d2 in this case we can write on v, value of v is a times t. So this is the total time. This time is the 1 second, means this entire interval of time, and we have minus half, we have a, and this is also 1 second, means time taken to move from this point to this point, from time t minus 1 to time t. So this interval of time is 1 second. So this is 1 second, and this is that interval of time. Now if we simplify this one, in this case we will get this is 80 minus we have this is a by 2. So this is value of d2. we need to find out difference between D1 and D2. So we can go back to this one and we can write down here. We have this is AT minus we have A by 2 and we have minus this is A by 2. So this one is A by 2. Now if we simplify this one, we will get this is 80 minus we have A, because A by 2 is equal to A, and from here we can take A common, so we be left with D minus 1. So this is the difference between D1 and D2, and this is our final answer. So this is what question is asking us to calculate. So the answer for this question is B. So this is how you can approach a very nice question about kinematics. I hope you have some understanding of this one. So this is how you can answer this type of problem. Beautiful question. If you didn't understand this time, look at this question again, read question again, and try to do by yourself. Because if you want to improve your understanding of physics, when you study online, when you watch these videos, you have to do these questions first of all by yourself. Because watching videos and watching movies means watching videos for study and watching movies, they are different. When you study online, you watch videos, you have to do questions by yourself. And where you stuck, you need to watch the video and you need to improve yourself step by step. For question number 7, it is given to us a person standing on a horizontal floor is acted upon by two forces, the downward pull of gravity and upward normal force of the floor. These two forces, do they form action-reaction pair or not? So let's try to understand first of all conditions for action and reaction forces. Conditions for action reaction pair. So this point we need to understand because we see action and reaction pair in these answers. So let's try to understand action and reaction pair. Two forces, they can form action reaction pair if they have the same magnitude and opposite in direction. So first condition is that if they have the same magnitude. Second, opposite directions. If they have opposite directions. And the third condition is that same type of forces, means gravity, reaction will be gravity. Normal reaction force, pushing force, reaction will be pushing force. Same type of forces. And the fourth condition is that act on different bodies. On two different bodies. Yeah, simply we can say act on different bodies, not acting on the same body. Now let's try to find out the best possible answer for this question. Now it is given to us a person standing on a horizontal floor is acted upon by two forces. It means these two forces, they are acting on the same person. So it means they do not form action reaction pair because they are acting on the same person. So not action reaction pair because these two forces, they are acting on the same person. But if they form action reaction pair, they have to act on different bodies. So we can say not action reaction pair, or simply you can say these forces, they do not form action reaction pair. So this is one thing we can conclude from this given statement. So if we look at option A, equal magnitude and form action reaction pair, no, they do not form. Second one, have equal magnitude, yes, and do not form action reaction pair, this can be possible answer. Have unequal magnitude. If unequal magnitude of forces acting on this person has to accelerate, that this person is at rest. It means the magnitudes are equal. Form action reaction pair, no. Unequal magnitude, no, they have equal magnitudes. They do not form, yes, this is right. So the answer for this question is B, because they have equal magnitude. That's the reason the person is at rest. They have opposite directions and they are not same type. Because this is the gravity and this one is the pushing force. So they are not same type of forces. So they do not fulfill this condition, and also they are acting on the same body. So they also don't fulfill this condition. So that's the reason they do not form action reaction pair. So the answer for this question is B. B. For question number 8, we need to find out which of the following graphs best represents the force of friction on an object starting at rest that eventually starts sliding across a level surface due to a gradually increasing horizontal force. Now let's try to understand first of all how the applied force and frictional force, they are linked with each other, the relationship between two forces. Imagine that this block is placed on the ground. So we can simply imagine that this block is placed on the ground and we apply force on this one. Let's say this one is the applied force and this force is 1 Newton. So this is the applied force, and block in this case is not moving. If the block is not moving, it simply means that the frictional force acting on the block in the opposite direction, that frictional force is also equal to 1 Newton. Now imagine that we increase applied force. This applied force becomes 2 Newton now. So this frictional force also, this will be 2 Newtons. So there is a linear relationship between these two forces. And let's say we even apply more force and the applied force is 3 Newtons now, but block is still at rest. So this static friction, this will be 3 Newtons and so on. Finally, at one stage, the value of the friction will be limiting friction, means the maximum friction. And after that, the block will start sliding, start moving. So we will reach limiting friction. And after that, block will start moving. And this static friction, this becomes kinetic friction. And kinetic friction is less than static friction, and kinetic friction remains constant. It does not change with applied force. So static friction changes to kinetic friction. Kinetic friction when the block is moving. So we can say kinetic friction when the block is moving. Static when the block is at rest. So we can say for moving, when the block is moving, the friction is kinetic. When it is at rest, friction is static. And static friction is greater than kinetic, means the limiting friction is greater than kinetic friction. So this knowledge you need to answer this problem. Now if you look at option A, this one is not possible because after that kinetic friction has to be constant. So this one is wrong, this is not possible. Option B is also not possible because this one is not constant. So this is not possible. And this is also not possible because this is telling you it is increasing, not linearly. So it means this is also not possible. So the answer for this question is D. So this is how you can figure out answer. So this is very important graph for applied force, or you can say opposing force, and this one is the friction. So this is kinetic friction. So this horizontal line, we can say this is representing kinetic friction, and it does not depend on applied force. And until here, this one is static friction, means when the block is not moving. So we can say this one is static friction. At this point, this one is the limiting friction, means the maximum value of static friction. For question number 9, it is given to us two objects have a mass 1 kg and carry a charge of magnitude 1 coulomb each. Which statement correctly identifies the relationship between the magnitude of the force of gravity and the magnitude of the electric force between the objects? So first of all, we can sketch these two objects. Imagine that we have one object. This object has mass 1 kg, so its mass is given to us, and the charge on this object is also given. Let's say this is 1 coulomb. The charge on each object is given, that is 1 coulomb. So we can say this is object A, and let's say we have another object, and the mass of this object is also 1 kg, and the charge on this object is also 1 coulomb. We need to find the relationship between gravity and electric force or coulomb force. First of all, we can write down for gravity. Gravity is equal to G capital M small m. So in this case, we have two masses, mean G m1 m2 divided by the distance between them. And we can also imagine that the distance between them, just imagine distance between them is equal to 1 meter. So we can divide by distance between the center. So this is d square. Here we can write down the coulomb force Fc. This one will be equal to K times Q1 Q2 divided by distance between these two charges. Now we can simplify. Value of G we have, that is 6.67 times 10 to negative 11 Newton meter square per kilogram square. And the mass of this one is 1, mass is 1, so simply this is 1 and it's multiplied by 1 kilogram, 1 kilogram. And the distance is also 1. And for Coulomb force, we can also write on K. K is equal to 9.0, about 9.0 times 10 to 9. And the charge is 1 coulomb, and the distance between these two charges is 1 meter. So this is 1 squared, 1 squared. Now we need to compare these two forces. So in this case, simply you can see FC is much greater than FG. So we can say FC in this case is equal to 9.0 times 10 to 9 newtons, and FG means the force of gravity, that is 6.67 times 10 to negative 11 newtons. So Coulomb force, electric force, is much greater than gravity. So the answer for this one has to be gravity is much smaller than electric force. So the answer for this one is B. So this is how you can figure out. Even you can find the ratio between them. If they ask you to calculate ratio, I mean FC divided by FG, we can also calculate. So here we have 9.0 times 10 to 9, and this is divided by 6.67 times 10 to negative 11. About, we can write down, this is 11 plus 9, so this will be about 10 to 20 times greater than the gravity. The electric force is about 10 to 20 times greater than gravity. So you can also calculate ratio between these two forces. For question number 10, we need to consider the above configuration of masses. But for this configuration, it is given to us that rope has no mass and inclined plane is frictionless. And we have two masses. One mass is hanging here. This mass is M1 and this mass is M2. And acceleration in this case is up. I mean, this is direction of acceleration. So we can also draw one arrow here. So this is telling us direction of acceleration. And we can also draw force acting on this mass, the force acting down. We can say that force is M1G. And now we can consider forces acting on this block, on this mass. So one force is force of gravity that is acting vertically down. We can say this force is M2G. And there is also normal reaction force that is perpendicular to the plane, and this is at an angle of 90 degrees. We can say this one is N. But this block is not moving perpendicular to the plane. So it means we can resolve this weight into two components, and then we can try to find out value of force acting down the plane. So in this case, we have this angle is theta. This angle will be 90 minus theta because this is just triangle, and so this angle also will be theta. Now we can resolve this weight into two components. So we have one component here that is against normal reaction force. I mean, this force is balanced by this component, and there is one component of the weight that is acting along the plane, and this is acting down the plane, means downwards. Its direction is downwards. This component is with angle. We can simply say this is mg cos of theta, cosine of theta, and this component will be mg sine of theta. This is a typical question, so you need to understand how to answer this type of problems. Now this component of weight we can also simply draw here. So we can say this is acting along the plane, so this is acting here, and so simply we can redraw here. So this is mg sine theta, mg sine theta. Now we need to consider forces acting on the system. We need to calculate acceleration. We can say A, this one will be equal to F net divided by mass of the system. Mass of system. So in this case, we have two masses. So mass of the system is M1 plus M2 because rope has no mass. Now we need to consider these forces. So if you look at this mass and this mass, so on this mass there is one force that is acting down, that is M1G, and here is a force that is acting down the plane. We can simply redraw this one. So it is like this. It's a beautiful way to answer this type of problem. We have M1, there is a force that is acting this way. We can say this force is M1G, and there is force acting on M2. So this is M2. There is a force opposing M1G. That force is M2G sine of theta. These two forces are balanced, and this inclined plane is frictionless. So you see these two forces are acting in opposite direction. So we can find the resultant of these two forces, means the net force. Net force will be M1G minus M2G sine of theta. This will be divided by m1 plus m2. Now from here we can take g common, so we can take g out, so we can write down this is m1 minus m2, m1 minus m2 sine of theta. Because g is common, we can take that out and we can divide by m1 plus m2. So this is a smart way to answer this problem. We can also use a long way, but this is a smart way. If you have very good understanding of these problems, you can use this method. So in this case, we have close these masses in a box, so we no need to worry about tension, because tension is the same, so that will be cancelled. So there is a tension on this one that is acting this way, and there is a tension on this one that is acting this way, so tension will be cancelled. So we no need to worry about tension in this case. You can just imagine we close them in a box and we can consider forces acting on these masses forward, and this is backward, and you can find out. So the answer for this question is B, and this is the best way to answer inclined plane problems. I hope this one is clear. If you have any questions about this one, so please leave your question in the comments and I will be answering as soon as possible, and I will explain you with another method if you have questions about this problem. If you like this video and if you find this video helpful, so please like and subscribe, because your encouragement is very important to make more videos. See you in next video.